This talk that we are going to do today is once again regarding the potentials of AI in structural engineers, and we will also add today some challenges that we have to overcome. So what we are going to look at is AI itself a little bit, and also how we can use this in structural engineering in different contexts. So first of all, let me talk about these three senses. And because this, I think, is a basis for why people are finding it easier to connect to AI in some way, because it's about intelligence. It's about having a sense of things. And as you know, that everyone, all of us have this idea about the common sense, where we feel something is right or not right, and it's based on our previous learning and experience and exposure and education and everything. It's a combined effect of everything. And that's exactly how AI models are these days being trained in a very large models. And the second example that I normally give to many people is the driving sense, because this is actually, if you look at the driving, and let's take an example of on a two-way road where you have a car in front of you, and then you're driving behind it, and there's a third car coming from the other side, and you have to make a decision to overtake the car in front of you. Now, the amount of calculations and the data that is needed to do that is actually a lot. You have to know the speed of the two cars and your own car, and acceleration capacity, the distance, the time, and the gap between that, and how much risk you can take. And then you make a decision to overtake or not. And that's why the self-driving cars, with all of the AI and all of the sensors, are still finding it difficult to drive on two-way road. They mostly drive on roads which go in one direction at a time. And that's exactly where human beings excel, because they can learn a lot more from their experience and apply it very quickly without actually doing the real calculation. But their calculations are pretty much agreeing with physics. And sometimes you see some people can drive well, some not, some are good drivers, some take more chance. Sometimes some people just never overtake because they can't seem to get the calculation right in their mind. And then comes the design. Structural design, for example, to me is very similar to driving, because structural design is based on a lot of computations, a lot of data that we must compute, just like the driving. And in theory, we must always do those calculations to reach at a final design, just like the decision we make in the driving. But with experienced engineers and engineers who have actually explicitly learned engineering, they can make many decisions without actually having to do the calculation. It reminds me of my professor in undergraduate, and he used to brag about it. At that time, smoking in class was permitted. So he used to smoke a lot. And he would have a cigarette case with him, and he would say, I can design any building on the back of my cigarette case, the box, the paper box. And to some extent, it may be right, because there were no computers, so he has to actually train himself to do the computations quickly and reliably over time to explicitly learn from it. So now we have three cases that we actually can combine, and we can see the last one, heavily computing oriented, requires precise calculation, but still many experienced engineers can easily come up with the final answer quickly. And some just rely on the numbers a lot. Same thing is happening in medical profession. If you look at the past, the doctors in the past, even in some places now, they could diagnose many illnesses just by looking at few factors like the heart rate or the pulse rate. But now they need so many tests, and only then they can make the judgment. So it's a balance between how much we learn and how much we rely on pure data. Now let's get back to this image, and I will start with this image and end this with this image. This is an image of somebody trying to work on an old computing device, and as you can see, the people are watching from the outside in awe, looking at this person, how he can do that. And this happens with every technology. As soon as we see a new technology, some people adopt it, become experts in it, other people outside watching in awe, oh my God, this is magic. And for the person who's doing it, it's just routine. And once again, we are seeing the same kind of change happening. Another one, of course, very rapidly now with AI. So the future belongs to those who embrace technologies. People are saying already that future belongs to people who will embrace AI this time. And I want to talk about that and see whether that is really a correct statement or not. And that brings me back once again to the big claims that technologies make. This is an ad of a computer that I bought in 1982 as my first computer. And it was almost $100 at that time. And look at the caption. It says, finally, you can afford to satisfy your lust for power. And it has just 1K memory. And it has 26 variables to play with. And it says that this is the ultimate machine that you can do at that time. So the claims of technology have always been very tall and high, and many times they do not pan out. But let's see whether this time the AI's claims are, how will they start? So this time people are saying AI is different, or is it? So let's take a look at that and then move on to see if it is true, then we should adopt it. If it is not, then we may skip it. But the chances are that this time it's probably true. So let's look at the history a little bit. So AI started to be popular or recognizable since 1950. So it's almost 75 years now since it came into being. But we haven't heard so much of it because it was quietly being integrated into many things. Washing machines, many things had AI long before we talked about it. I remember Netflix, this company, when they started, they announced a competition saying that we want to develop a predictive program to see which movies people will like based on their choices and so on. And that was AI. And at that time, so somebody won $1 million competition. And AI is used in programs like that. And of course, in many things that. But what really changed is in 1920 and 22, when public became aware of that overnight almost, when ChatGPT was released. And suddenly everybody started to talk about AI because this is something that looked like AI of the books that we have, or the movies that we have seen. So ChatGPT came in, claiming the answer to many of the AI's claims. And then Gemini from Google came to compete with that. Unfortunately, they lagged behind. In fact, the technology used in ChatGPT is based on the research done at Google. So it's interesting that Google did not pursue it and somebody else took it and pursued it and made that. And then Gemini is now catching up with that. And then we have Claude, which is actually an offshoot of ChatGPT. Some people who were working in ChatGPT, OpenAI, didn't like what they were doing, too commercial. They started having on their own company, and the Claude came into being from Anthropics. And then most recent is the DeepSeek from China, which has once again rattled the entire concepts of large language models and AI, because it's much faster, it's much cheaper, and was done very quickly using fewer resources. So now we have these 4 players right now. There are many more, but you can say these 4 are the primary tools that are drawing attention to AI from everybody. There are a lot of work done in AIT that we don't see, but this is AI that we see. Now, this is the reason why people think it's different this time. First of all, the GPUs are being used for GPUs, the graphical processing units, which were originally developed for graphics processing. They have found that they are also suitable for AI model training, and this has changed everything. And companies like Naveed, they have made billions because of that. They become the most valuable company because of this. Then generative AI and the large language models are catching public eye. All these 4 that I showed you, this new revolution of generative AI, large and LLMs, have really opened doors to a new kind of AI. Then more resources are being allocated. Governments are putting in billions, not millions, billions into this one. And then the other factor is there's a feeling of being left out. People are feeling that, oh, I'm not doing anything with AI, or company who is not having AI application seem to be not catching up. So almost every software that you're using has an AI button somewhere, because people are just trying to make sure that they are thought of as being, in on AI. And then the governments are stepping in to make regulations and all, just like Bitcoins, So this is like a big thing at the moment. So let's come back to our own field now, and to engineering and to structural engineering. So we know very well that engineering is not math. But it uses math, it's based on math, but there's a big difference between math and engineering. Engineering involves so many other things, like if we don't use necessarily the exact things. We are used to rounding off. We have the factor of safety to account for the judgment and for other factors that we cannot compute. And then we have the probabilistic way of rounding things up. So all this makes engineering and many other fields, although based on math, not exact math. So which means that there is something more going on beyond computations. And that's where the potential of AI will lie. I give you a very simple example of a beam, and let's say we have the same beam. In one, the load is 10, another one 10.8. If you do the analysis and the design mathematically correctly through computations, you might receive the area of reinforcement in one as 1255, but you will round out to use 3d25 bars. And if you increase the load a little bit to 10.8, the area will definitely change through computation, but the end results will not change because we still need to use practical bar sizes and practical consideration. And this is the kind of difference that you can see between AI models and the computations. And this is an acceptable difference in our case. In math, is not. But in engineering, it may be. So that is where the potential will lie for AI to come in and give us those reasonable numbers because they give us the end result and don't care about the computations in between. So this is another example where things could be very different. So I normally talk about this in my class every time. And I say that if you give this task to the engineers, that is a tank which is a length and height and thickness given, can you design the reinforcement? And they will come up with the reinforcement in all places with all the mathematics, all the calculation, wall, slab, base, everything. And then you can construct it according to that, although it will have to be rounded off later. But if you give them the problem in a different way and say, okay, give me the best water tank size, shape, proportion to contain 1200 cubic meters of water, so many options are there because we don't know where to start, because now every shape has a possible solution. And until we go through the whole design, we can't know which one is the best one, and that's not practical. But once again, AI has a potential here to be trained on this and then can directly lead to a good answer or acceptable or a reasonable answer. And this brings us to changing our workflow in engineering design, because we are used to following this step-by-step A to Z, A, B, C, D to Z approach. But AI doesn't do that. It can go from A to Z in one step once it is trained, or Z back to A if it is trained properly. So that's what we can do. So instead of iterative loop and step-by-step loop, we can just jump to the prediction directly. Like, for example, we can start with the architectural design and we can jump to the code-based design outcome and even to the performance-based design outcome if we have used sufficient models to train our AI, so that we can get to that results. But of course, we have no calculation to prove it, so you can't submit it to the authorities, but you will have the outcome anyway. So one more thing, that the LLMs or the large language models or generative AI is very good at explaining things. So, for example, if you give this image to one of the language models that I mentioned, it will give you, in this case, OpenAI's, it will give you a very good description of what this image is. It's just a bunch of pixels, but it can interpret it absolutely accurately, what this image means and where to use it and how to use it, and it can do better than most engineers. So that's because it has been trained on the description of these things by engineers on different areas, and it has learned how to put things together to make a sensible outcome. So you can see that now LLMs AI can be used for this purpose to create descriptions of the things that we don't know. It can also give us the opportunity to do things that otherwise we do not have the knowledge to do, because many times we don't need in-depth knowledge for everything. Often we just need enough knowledge to start something and then have other people who know the details to get into that. The first level of getting into a project or meeting a client or talking about something, we need to have some material. And AI or language models are good enough to give you that first introduction. In fact, last week, somebody wrote me a very nice application for a job, and I thought this guy is the perfect person for our position because the application was so well written, so directed. But when we met the person, we realized that he doesn't know much because it was written by AI. So AI can actually put up something very nicely if we instruct it properly. So now comes to challenges. The first challenge in our field and in many fields is going to be the data. At this point, all of these 4 language models, big ones, they have consumed all available public data. They just don't have anything more to train. So now they're hiring experts to actually generate more data for them, and so on. So data can be taken from public domain. It can be a collaborative data by having collaboration with somebody. It can be organizational data, and this is where we come in. Our design firms, our organizations have a lot of data which is kind of private or restricted, and that still can be used for training. And then individual knowledge experts, and then generated data. The last one is the most interesting one because in our field, we are in a very good position to actually generate data. For many things, data cannot be generated. Real data has to be taken into account. But in our case, we can actually generate data that can be used to train the models, and I will talk about it in a minute. This is the first application of that idea. So this is a very simple problem, beam design, and this is based on the same idea that we can actually design 10,000 beams of all combinations of span, height, length, loading, or 20,000 beams, retain the ones which are perfect or passing all the design are within a certain acceptable limits, and use them to train, and then after that we can come to the design directly, as I mentioned to you earlier. So this is one of the ways that we can do that. Last year when I presented, it was just an idea. But this year, one of our students in AIT has actually completed this research, and this is what he is doing. And he went one step ahead and integrated his research with the large language models so that it can become a more of a conversational design rather than a data input and output in the traditional sense of the AI. So this is a video from his thesis. So you can watch here that he is now conversing with the model that he has developed. This is based on about 10,000 beams that were generated through programming, and all the valid results were saved for all variations. The model was trained, and then after that we were verified, and we determined that it's almost always giving a good answer because we keep 20% of the data for verification, and based on that, now it can give you all the design very quickly. It can go on to give you the combination of the syrups, explain what it has done, and if you go further, it will also do the cost calculation by inputting the basic information. So as you can see here, that for every possibility of it can give you the design. But the interesting thing is not about only the design. It can also go backwards. So if you give the beam data, it will be able to give you the capacity. And because we have the same data, input and output, we just reverse it. And then the AI model can give you the reverse answers by retraining the model in the reverse way. And then you can say that we can get capacity from that, as this prompt is saying. And then it will tell you, okay, this is the one that I want to use. And then you say, this is the moment capacity and so on, and load capacity. So this is the example of where we can generate the data and we can train the model and we can use it to predict low cost or economical or safe or whatever beam, and we can also go back and forth. And we can choose any output as input and get the others as output. And that's so for this particular case, he trained 20 separate models, not one, so that we can do multiple queries for the same data. So this is one. So before I move on, I just want to clear one point. The difference between finite element analysis and AI. In fact, both of them are very similar. The only difference is that this is based on exact relationships and AI is based on estimated learned relationship. Other than that, it's the same. It's a matrix. It's the same way. It's a huge matrix of parameters related to other parameters through a matrix with the weighting functions, just like our FEA. So if you go to FEA, we have a matrix that links everything together, and those matrices are exact in case of structural analysis, but in case of the AI, they are derived, the coefficients of the matrix are derived through the AI learning, because we know the output, we know the input, and we find out what matrix made it possible, and then they are interpolated, and then they are trained to answer for multiple cases. They can never match the exact accuracy of the original matrix, but will be close enough. So we can use that to train the models, like I mentioned to you, for tall buildings, mostly in Philippines, these buildings, and then you can train them to actually predict the outcome, the amount of reinforcement required in a core wall, the initial period, and something like that. But we didn't have enough data at that time. This was done about 10 years ago, and now we can now generate more data, and I'll show you about that also. So you can predict many things from that data, because it's trained on real projects. But real projects data is hard to come by, so you can simulate real projects through data generation, as I mentioned to you. So this is the example for a bridge, and our new program, CSA Bridge Express, which we presented last time in Philippines two weeks ago. And here, one of our student again took this program and wrote the back end to generate thousands of beams and train the model, because this program has a fully integrated, so we can get all the analysis and design and calculation and quantities and everything done in one cycle. So if you link it back to a data generation module parametrically, then we can do that, and we can come up with this program, which is a conversational bridge design AI-driven module, and it is trained on the data from the bridges. From that program, valid data, only the bridge that passed the design are stored, and based on that, we can develop the whole thing, and then you have a conversation here, and then based on that then we can see that after the conversation is over and everything is valid, then it should give you, and it also checks your data if the data you are trying to input is wrong, and it just gives you various design options. And you can see here the design 1, design 2, various valid design options come up, and then you can choose one of them, and then it will link back to the main program, send the data to that program, so you can actually now create the model, do the analysis and design. So the AI is now used as a preprocessor to help you find the starting model that will pass. And that's always a challenge, to start with a model that is valid. And here we have it because it's trained on the right data. So this way, a lot of work can be done moving forward with different programs. And this is where the potential lies. Now let me move on to another area where AI can help the engineers with the programs. For example, here in the same program, we have put what we call AI-enabled editing. So you don't need to actually find the parameters to edit or data edit. You just converse with the program and say, I want to change this one in normal human conversational way, and it will find the correct data and change those parameters. Imagine you don't need to learn the program anymore. All you need to do is give the instructions in a sensible manner, and the AI will find the right data, update it, and then change the data and show you there. For example, in this one, we changed the number of the spacing and number here, increase the number of columns to 3 and the spacing to that one, and it does that. And this is without entering any data, just by conversation, because AI is helping us communicate with the program through this one. Once again, another good application here. This one is another application which we are working on. You take a picture of the structure, and then you drag that picture onto this program, and it will estimate the size and the bracing and the shape of the tower and get the basic geometry and generate the model from there. So this is picture to model or image to model, another AI application which can save us tremendous time in initial starting the project. So now you can see several ways AI can help us. Then we can use AI for specific needs, to customize it. And like, for example, as I told you, you have the data in your company, you have your organization, you can use that data to train the AI, which will be specifically working with your company's data, and so it will be very focused and relevant and not give you data which is invalid. So this is another area that we can do. So for example, you can use ETABS to train the models and then use ETABS again to do the design. And so that way you can use a consistent system without the chance of, as long as, of course, you rely on ETABS, which you should, because maybe people have been using it for a long time. So you can use reliable AI models through reliable input. That's the main key. So AI still can't replace engineers. People keep asking me, will AI replace us? And I said, no, not yet, because we still need a lot of reasonable oversight to make this happen. So, for example, ChatGPT can pass the medical, law, and business professional exams, but it cannot pass the engineering. I made this statement last year, and I'm making it still. So after 1 year of development, with all of the billions of dollars going there, this is still something that the language models or the AI can't handle, because our work is more precise, requires precision, and more critical thinking. So because it has multi-dimensions, and then that's why it is still difficult. If you see architects, engineers, these are people who are still going to be safe for a while. And until the language models become what they're saying, they become general AI. That means they can answer everything, and they have all the data combined together. For example, they get the information from everything together, and they're going there. They can connect to internet now, they can connect to media. Right now, AI can do images separately, drawing separately, models separately, but once they combine everything together, then they will have the capability to be very human-like. So before that happens, we should get in and make sure that they learn from us, not from somebody else, so that they are still. So that's where I would like to propose the master-apprentice paradigm, where one master can train many assistants, and then they can do the job similar to the master. So this apprentice, so AI can learn from many masters and train many apprentices or work for many apprentices. So we have to make sure that AI learns from the real data, reliable data, and it's not. For example, I often talk about Naveed, because at that time, in his time in Italy, he designed these masterpieces without computers, without much. But people like him are still needed to make sure that the AI has that quality of the masters. So let's imagine a world where AI partners with master engineers, or master programmers, master programs like ETABS or SAP or whatever you use, and then they create tools that will enhance the creativity, increase the efficiency, and multiply the expertise. So everyone, all engineers, have a certain level of basic knowledge, basic capability. It will be good for the profession, because then even the people who haven't got the experience have the capability to benefit from the experience. So the quality of the work will improve, and the final outcome for the society will be better. To me, that is the key focus of AI in our profession. So we have to avoid all the pitfalls, as I mentioned. The first one is that we should do the thinking, not AI. Just keep AI as a tool. Don't believe in AI to start with. Believe in yourself and get something out from AI to support your work, not to make your, to guide your thinking. That's the most important thing, in my opinion, at this point. Treat it as a tool and an assistant, and then use it to enhance creativity and not replace critical engineering computations. Adopt it with understanding, caution, but not shun it, because that will be bad for our profession. Take control of it before it takes control over us. So with that, let's get back to this one. And only I add that taking advantage of the potentials and avoiding the pitfalls. And I hope that this talk and things like that will help our profession to make sure that AI, whichever way it's going, we are part of this and we are in control of this. So with that, I would say thank you so much for listening.